Good morning, parents, teachers, and learners. Welcome to Valenzuela Live. We are now on our week 8 of quarter 4 in Statistics and Probability. I am Miss Judith Alicia of Valenzuela National High School from Senior High School Department. For today's lesson, we are going to learn more about the Pearson sample correlation coefficient. Now, let us first have the most essential learning competency that we need to attain today. First, calculates the Pearson sample correlation coefficient. Second, solves problems involving correlation analysis. Before we begin our lesson for today, let us have an activity. This activity is called Let's React. I will be showing you statements and you need to identify if it is true or false. If your answer is true, just press or click the heart emoji. And if your answer is false, just click the like button and I will give you 5 seconds to think of your answer. Are you ready? Let us now start. For statement number 1, 0.001 can be a representation of correlation coefficient R. Is it true or false? Your timer starts now. Yes, the answer is heart. It is true. Remember that correlation coefficient ranges from -1 to +1. For statement number 2, negative relationship means direct relationship. Is it true or false? Your timer starts now. The answer is lie. Yes, it is false because negative relationship means inverse relationship. For statement number 3, if the coefficient of correlation falls between 0.51 to 0.74, there is a high negative correlation. Is it true or false? Your timer starts now. Very good. The answer is heart. Yes, it is true because in qualitative description of correlation, the 0.51 to 0.74 falls under the moderately high correlation. For statement number 4, in the Pearson R, N represents the sum of X values. Is it true or false? Your timer starts now. Very good. The answer is lie. Yes, it is false because N is the number of paired sample of X and Y. Good job, my dear students. Let us now proceed to the next part of the lesson. Let us now define the word correlation coefficient. The correlation coefficient R between sets of the data is a measure of how well they are related. It is a measure of the strength of the relationship between or among variables. The most common measure of correlation is the Pearson correlation. Distribution can correlate positively, negatively, or not at all. At a glance, correlation coefficient R tell us strength of association or linear correlation between the two variables. The sign of the correlation coefficient, positive or negative, describes the direction of relationship between two distributions of scores. The correlation coefficient ranges from -1 to +1. The closer the coefficient to -1 or +1, the stronger the relationship. The strength of correlation is indicated by the coefficient of correlation. There are several coefficients of correlation. One that is most used is linear correlation. It's Pearson product moment correlation coefficient. There are several types of correlation coefficients, but the one that is most common is the Pearson correlation, or R. This measures the strength and direction of the linear relationship between two variables. It cannot capture nonlinear relationships between two variables and cannot differentiate between dependent and independent variables. In this lesson, we are going to calculate the Pearson sample correlation coefficient. The Pearson sample correlation coefficient, also known as Pearson R, denoted by R, is a test statistics that measures the strength of the linear relationship between two variables. To find R, the following formula is used. R is equal to N multiplied by summation of X and Y minus summation of X times summation of Y all over by square root of N multiplied by summation of X squared minus the square root of the summation of X multiplied by N times summation of Y squared minus the square root of the summation of Y, where N is the number of pairs of scores. Summation of X and Y is the sum of the products of paired scores. Summation of X is the sum of X scores. Summation of Y is the sum of Y scores. Summation of X squared is sum of X squared scores. And summation of Y squared is the sum of Y squared scores. Next is Pearson product moment correlation coefficient. Looking at the left column of the table, it shows all the possible answers that we can get by using the Pearson R formula, along with its qualitative description on the right column. For positive and -1, it has a perfect correlation. For positive and -0.75 to positive and -0.99, it has a very high correlation. From positive and -0.50 to positive and -0.74, it has moderately high correlation. For positive and -0.25 to positive and -0.49, it has moderately low correlation. For greater than 0 to positive and -0.24, it has a very low correlation. For 0, it has no correlation. Let us now have an example. Find the coefficient of correlation and interpret the relationship between the two sets of test scores in algebra and geometry of 10 students as shown below. On this table, there are 10 students and their corresponding test scores in algebra and geometry. Algebra represents the X values and geometry represents the Y values. In finding the value of R, we need to complete the table. The first step is to get the product in each element of X and Y. For student number 1, 18 multiplied by 19, the product is? Okay, very good. It is 342. For student number 2, 15 multiplied by 17, the product is 225. For student number 3, 13 multiplied by 14, the product is 182. For student number 4, 16 multiplied by 15, the product is 240, followed by 110, 156, 210, 130, and 238. The second step is to get the square of each element of X. $18 multiplied by 18, the product is 324. Next, 15 multiplied by 15, the product is 225. 13 multiplied by 13, the product is 169. 16 multiplied by 16, the product is 256. 13 multiplied by 13, the product is 169, followed by 100, 169, 225, 100, and 196. The third step is to get the square of each element of Y. For student number 1, 19 multiplied by 19 is 361. For student number 2, 17 multiplied by 17, the product is 289. For student number 3, 14 multiplied by 14, the product is 196. For student number 4, 15 multiplied by 15, the product is 225, followed by 196, 121, 144, 196, 169, and 289. The last step is to get the summation of each column. For the summation of X, we have 137. For the summation of Y, we have 146. For the summation of X and Y, we have 2045. For the summation of X squared, we have 1933. For the summation of Y squared, we have a total of 2,186. Let us now substitute the given from the formula. So R is equal to 10 multiplied by 2,045 minus 137 multiplied by 146. All over by square root of 10 times 1,933 squared minus the square root of 137 multiplied by 10 times 2,186 squared minus the square root of 146. Performing the indicated operations, the answer is 0.811. So now let us interpret. Since R is 0.811 is closer to positive 1, there is a strong positive correlation between the test scores of algebra and geometry. Let's proceed on example number 2. Correlation coefficient. Below are the data for 6 participants giving their numbers of years in college, or X, and their subsequent monthly income, or Y. Which of the following best describes a correlation between X and Y? In finding the value of R, we need to complete the table. Okay, for the values of X, we have 0, 1, 3, 4, 4, and 6. And the value for Y, we have 15, 15, 20, 25, 30, and 35. So the first step is to get the product in each element of X and Y. Zero multiplied by 15, the product is 0. How about 1 multiplied by 15? The product is 15. Very good. Next, 3 multiplied by 20, the product is 60. Good job. How about 4 multiplied by 25? The product is 100. Very good. Followed by 120 and 210. The second step is to get the square of each element of X. 0 multiplied by 0, the product is 0. 1 multiplied by 1, the product is 1. 3 multiplied by 3, the product is 9. 4 multiplied by 4, the product is 16. 4 multiplied by 4, the product is 16 again. And 6 multiplied by 6, the product is 36. The third step is to get the square of each element of Y. So 15 multiplied by 15, the product is 225. 15 multiplied by 15, the product is 225. 20 multiplied by 20, the product is 400. Followed by 625, 900, and 1,225. So the last step is to get the summation of each column. For the summation of X, the total is 18. For the summation of Y, we have a total of 140. For the summation of X and Y, we have a total of 505. For the summation of X squared, we have the total of 78. For the summation of Y squared, we have the total of 3,600. Let us now substitute the given from the formula. So R is equal to 6 multiplied by 505 minus 18 multiplied by 140 all over by the square root of 6 times 78 squared minus the square root of 18 multiplied by 6 times 3,600 squared minus the square root of 140. Performing the indicated operations, the answer would be 0.950. So let us now interpret. For the interpretation, since 0.950 is closer to positive 1, there is a strong positive correlation between number of years of college and the monthly income. Let us try to solve this problem to know more about Pearson's sample correlation coefficient. Complete the table below. Fill in the blanks in the formula to arrive at the computed Pearson R. Then interpret the result. First, let us find the product of X and Y. What do you think is the product or answer for number 1? Okay, very good. It is 75. How about the product for number 2? Okay, it is 69. How about the product for number 3? Good job. It is 88. And for number 4, the product would be 90. And for number 5, we have the product of 75. Second, let us get the square of each element of X. What do you think is the answer for number 6? Yes, it is 529. How about for number 7? Very good. It is 121. And for number 8, we have 81. How about for number 9? The answer is 225. And for number 10, we have 400. Third, let us get the square of each element of Y. For number 11, the product is 25. Very good. How about for number 12? The answer is 9. Good job. And for number 13, we have 400. And last, get the summation of each column. For number 14, the summation of X is 93. For number 15, the summation of Y is 54. For number 16, the summation of X and Y is 797. For number 17, the summation of X squared is 1561. And for number 18, summation of Y squared is 662. Let us now substitute the given from the formula. Performing the indicated operation, the answer is negative 0.255. Let us now interpret. From Pearson product moment correlation coefficient table, the range from positive and negative 0.25 to positive and negative 0.49 has a moderately low correlation. Good job, grade 11 students! To generalize our lesson for today, answer the following statements with true or false. For number 1, a positive and a negative relationship may have the same strength. Is it true or false? Your timer starts now. Yes, it is true. For number 2, the most common measure of correlation is the scattered diagram. Is it true or false? Your timer starts now. Very good. It is false because the most common measure of correlation is the Pearson correlation. For number 3, in correlation, there is a cause and effect relationship. Is it true or false? Your timer starts now. Yes, it is false. Because a cause and effect is a relationship in which one event makes another event happen, while in correlation, there is no cause and effect relationship. There is only a causal relationship between the variables. For number 4, the correlation coefficient R between sets of the data is a measure of how well they are related. It is a measure of the strength of the relationship between or among variables. Is it true or false? Your timer starts now. Yes, the answer is true. Good job, grade 11 students. For your assessment, answer page 34 assessment part of your statistics and probability learning packet. And if you have questions and clarifications about our lesson for today, kindly coordinate with your subject teacher during your follow-up session. Before we end our discussion, I will leave you with the words of the great William Paul Thurston. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. That ends our discussion. Thank you for listening and see you on our next Valenzuela live streaming session.